All right, so we're going to try this one more time. So from the last video, what we did is we started off with an angle. So we knew what one of the angles were in our triangle, or sorry, not triangle. We knew one of the angles in our polygon. So let's suppose we have the same exact scenario. We know that it's a regular polygon. So we know we're talking about a regular polygon, which means we know that all the sides are the same. And in this regular polygon, one of the angles, or we could say all the angles, are equal to 168 degrees. So we know all the angles are 168 degrees. The question is, how many angles are there? Well, what we do know is that if we wanted to find the sum of the angles, by definition, we could just say, well, we're going to take the 168 and we're going to add it to every single angle in that shape. So we're going to add up all these 168s together. The problem is we don't know how many 168s there are, but we do know that we're just going to add them all together. Now, since we don't know how many 168s there are, it's virtually impossible to do this. So what we're going to do is we're going to say, well, I know that n is often used to describe how many sides or how many angles are in the shape. So I do know that there are n of these angles 168. So I can say n times 168, if I knew what the n was, that right there would give me my sum. But I have a second equation, and my second equation is that s is equal to the number of sides minus 2 times 180. So if I wanted to, I could solve this equation instead. So what I could do is I could say, okay, so sorry, not solve this equation. What I could do is I could say, I know that these two things, this here, right, n times 168 will equal the sum of the angles, and this thing right here, n minus 2 times 180, will also equal the sum of the angles, which means they must equal each other. So this 168n, right, this n times 168, must equal this 180n minus 360. It must equal that guy right there as well. So I know that it has to equal the 180n minus 360, which means we can now solve it. We can actually figure out what this is. If I was to subtract the 168n from both sides of the problem, minus the 168n, this would give us 0 equals 12, 12n, minus 360. This I solve. So it's set to 0, so all I have to do is add the 360 to both sides, add the 360 to the left and the right, and I get 360 is equal to 12n. Divide both sides by 12, and we now know that our n is equal to 30. So what we're looking at here is a 30 gon. Okay? So if you didn't understand this, go back to the first video, take a look at the first video, and hopefully this will clear things up. If it doesn't, there is a question. There are some questions in the textbook that you could take a look at that might be a little bit, a little more helpful in explaining how to do the problems. But I think these two should pretty much clear it up for you. All right. So for today's notes, I do need you guys to kind of write some new things down. What we're going to be talking about is the exterior angles. So what we first have to do is we have to understand what the exterior angles are. So we're going to start off with exterior angles. Okay, so my explanation of an exterior angle is it's the angle, it's a angle that forms a linear pair with an interior angle. Okay, so it forms a linear pair with an interior angle. Now, if you haven't written this down in your notes, you might want to take a chance to write this down. Stop, pause the video, whatever. But you definitely want this definition. The exterior angle is an angle that forms a linear pair with an interior angle. So let's take a look. So let's suppose I have this goofy looking, I guess we could draw a pentagon. So let's say I have this goofy looking pentagon right here. Now, if I wanted to look at the interior angles, then I would say that I have all these interior angles right here. So this guy right here would be an interior angle, okay? Now, if I want to get an exterior angle, what I would need to do is I would need to draw an extension to make a linear pair with this. So if I was to extend this guy right here, okay, so if I was to extend that side, okay, what I would have is I would have two angles, the angle on the inside, the interior, and the angle on the outside, the exterior. Now these two angles are not congruent to each other, but they are supplementary to each other because they are a linear pair. So we know that these two angles are going to add up to 180. And then we have this guy over here, another one. So we have another exterior angle. So what I'm going to do is I'm going to call this angle angle A. And then I'm going to call this angle over here angle B. Now if I extend this guy over here, I get a third linear pair right here. And we can call this guy C. And then a fourth linear pair over here. We can call this guy D. And then finally a fifth linear pair here, calling this guy E. Now, something that's impressive is that these angles, the exterior angles, will always add up to the same amount regardless of the number of sides that the shape has. So in a triangle, they're always going to add up to the same thing. It's going to add up to the same exact thing that a quadrilateral's exterior angles add up to. And this is what we call the exterior angle theorem. Okay, so to show you how the exterior angle theorem works, the first thing I want to do is I want to just take a look at this right here and say, okay, well, how many sides are there? Well, we know that the n is equal to 5 because it's a pentagon. Now, it's not a regular pentagon. All these angles are all whatever they want to be, but I know that n is equal to 5. And we go back and we take a look at the interior angle theorem, right? The interior angle theorem says that the angles must add up to n minus 2 times 180, or in this case, have to add up to 5 minus 2 times 180, which is equal to 3 times 180, which is equal to 540. So I know that all the angles on the inside have to add up to 540. So all these angles right in here, they are all going to add up to 540 degrees. But if we think of it this way, all the angles on the inside have an angle on the outside that they are linear pair to. What that means is that every single pair of angles have to add up to 180. So these two guys right here have to add up to 180. And these two guys right here have to add up to 180. And these two guys right here also 180. And these two guys also 180. And these two guys 180. And if you look at that, you'll notice that you have 1, 2, 3, 4, 5. You have 5 180 degree linear pair angles, which equals 5 times 180 comes out to 900 degrees. But of the 900 degrees, 540 of them are interior angles. So these guys right here are all the interiors. Now if I took the 540 and I subtract it, right? So if I took the 540 and subtract it from the 900. Now remember, the 900 is the interiors and the exteriors added together. If I took the 900, which is both the interior and the exterior, and I subtract the 540, if I subtract just the interiors, this answer right here will be the exterior angles. So if I subtract these things, borrow from that guy, I'll get 0, 10 minus 4 is 6, 8 and 5 is 3. I will get 360 degrees. And this is our exterior angle theorem. So you're going to want to write this guy down in your notes, the exterior angle theorem. So I'm going to get rid of this right here. And we're going to write down the exterior angle theorem. Now remember, the exterior angle theorem states the exterior angle theorem. The exterior angle theorem states that the sum of the exterior angles of a of a polygon, you can say convex polygon, but I'm not going to stress the convex part of it because that's the only thing we're really going to be studying in this class. The convex polygon is 360 degrees regardless, and you don't have to write this part here, parentheses, regardless of the number of sides. So no matter what the number of sides is, the exterior angles are always going to add up to 360. Now, it would be a silly question for me to have a question like this, but I guess I could ask it on a test or on a quiz, be like, hey, all right, so question number 1, example. what are the exterior angles of a dodecagon going to add up to? All right, that's a silly question because the answer, regardless of the type of polygon it is going to be 360 degrees. So no matter what, it's always going to be 360 degrees. Now, a more appropriate question that you guys might get in class would be something like this. What is the measure? What is the measure of an exterior angle of a regular twelvegon? That's a better question. Now, what we need to remember here is that we're talking about a regular polygon. That means all the angles are the same, which also means that all the interior angles are congruent to each other, and then all the exterior angles are congruent to each other. Now, since we know that this is a regular twelvegon, we know that there are 12 angles that are all the same, but because we're talking about the exterior angles, we know that the sum of the exterior angles is going to equal 360 every single time. Remember, that's what this theorem up here says. Regardless of the number of sides, it's always going to add up to 360 on the outside. So what we do know is that all the outside angles add up to 360, and since this is a twelvegon, we now know that if we divide this by 12, it will give us every single exterior angle. All the exterior angles are all going to be 30 degrees, which means, think about that, if the exterior angle is equal to 30 degrees, then what does the interior angle have to equal? What do you think? Should it also have to equal 30? What's the relationship between all the interior angles and the exterior angles? Do you remember? Yeah, they're all linear pairs. So these two angles have to add up to 180. These two angles have to add up to 180. So if one of the angles, by the way, that is not a twelvegon, if one of the exterior angles is 30, then we now know that the interior angles all have to be 150 degrees. Now it's this theorem here that gives us another approach to the problem we just did. And we'll take a look at that in the next video.